And our last question. Use algebra to solve. This time I notice I have a cos squared and a cos. So this time I have a quadratic equation. How do we solve quadratic equations? We move everything over to make one side equal to 0. So I am going to move the 3 cos squared x to the left. I still have a plus cos x on the left. I'm going to move the 1 over, gives me minus 1. And I make one side equal to 0. And when you have a quadratic equation, you have two options. You can either factor or use the quadratic formula. Okay? If, and unfortunately this one you cannot factor, but let's say you tried to factor. I want to show you, how do you know that something can't be factored? Well, if this could be factored nice, right? The only nice numbers that give you 3 cos squared would be 3 cos x and cos x. The only nice numbers that give you 1 for multiplying are 1 and 1. And if I look at what my outside is and my inside now, I would have a 3 cos x and a 1 cos x. Does that ever make 1? No. That's the only option with the 3 and the 1. So I can right away tell this cannot be factored. Because if it could be factored, those numbers would have to be there. So we have to go and use our quadratic formula. So we take out our formula sheet. On our formula sheet, we have this for our quadratic formula. This is for x squared. We have cos squared, so we would write cos x equals negative b plus or minus square root of b squared minus 4 times a times c over 2 times a. And with the plus or minus, there will always be two solutions, so we'll split it up. You would have one solution with the plus, one solution with the negative, and I'm going to type both of these into my calculator. And the plus one, I got 0.434, and .767, one positive, one negative. If I solve these and any of these was bigger than 1, I could right away say not possible. For sine and cosine, thinking about opposite over hypotenuse, adjacent over hypotenuse, you can't get a value bigger than 1 because that would mean that your hypotenuse is smaller than either your opposite or adjacent side. So then you could right away write not possible. That happens a fair bit on questions on the exam, so just a reminder of that. But since both of these are between 0 and 1, we can find our reference angle and solve. Again, how do we find our reference angle? I'll do cos inverse. I'll do this one first. This question in radians or degrees? In radians. So I'll go to my mode, make sure that I'm in radians. Again, we have to switch back and forth often. Cos inverse, and I get a reference angle of 1.12, dot, dot, dot. And so, in quadrant 1, it would be 1.12. The question says round to the nearest hundredth. And cos is also positive in quadrant 4, so I would go 2 pi minus my reference angle, and I get 5.16. Now the reason I have the dot, dot, dot is to show you never round an answer before your final answer. So my final answers are rounded correctly. If you round an answer early, there's a possibility that your final answer could be off a decimal place. And if you're off a decimal place on your final answer, that'll always be a rounding error, a half mark deduction. Okay? So again, on this side too, I'm going to do the same thing. I'm going to do cos inverse of the positive value and get a reference angle of 6957, dot, dot, dot. Cos is negative in quadrant 2 and quadrant 3, so I'll go pi minus my reference angle and pi plus my reference angle. 2.45 and 3.84. And I make a note that these are my solutions between 0 and 2 pi. And I'm about to get disappointed. If it was up to me, I would always set the domain to be 0 to 2 pi, so you'd be happy at this point. But what did the question ask? If we scroll back up, question?
I have a question.
Mm-hmm.
Isn't 2.45 in quadrant 1?
No, because if we think about 0, here's pi, which is 3.14. Half of pi as a decimal would be 1.57. So 2.45 would be in quadrant 2. We have to be careful when we're figuring out our reference angle. It's very easy to do cos inverse with the negative and get the wrong reference angle. Okay, so let's go back and see what was the domain of our question. Read back to the beginning, and they say negative pi to pi. So we have to say, what does that mean? Those are positive angles from 0 to pi and negative angles from 0 to negative pi. So our actual solution for x, can you see that quadrant 1, the 1.12 is okay? The quadrant 2, the 2.451 is okay. But quadrants 3 and 4 have to get changed. So now I have to think, well, what's coterminal with 5.16 with the same reference angle of 1.12 in quadrant 4? That would be negative 1.12. And I have to think, what is the angle in quadrant 3? I'll draw a little picture of it, with this same reference angle of 6.95. What would that angle be? Can you see that this angle in the negative direction would be identical, because we already figured this one out, 0.695. We already figured this one out to be 2.45. Does it make sense when we're going in the negative direction, then this will be negative 2.45 without having to do any extra mental math? And so those are the answers over the domain that they asked for. Now, in part B, they asked for the general solution. And again, for the general solution, I like to use my answers between 0 and 2 pi. The textbook likes to use the answers that they got in part A. So personally, I would use my 1.12, my 2.45, my 3.84, and my 5.16. Those are my answers between 0 and 2 pi. Write all of the general, all of the coterminal angles with them. So questions you can do for practice here. Circle 12, 13, and 14.